Okay, everyone, let's get started. This is not mine, and I just saw it here right now. So, anyone's? No? Okay, it's actually a pretty nice scarf, so if no one picks it up, I'm probably keeping it. Okay, all right. So, welcome, first of all. We are officially on week 5, and this week is lists. And if you guys all remember, up till now I've constantly been saying that the hardest part of this course is lists and recursion. And today is going to be our first time getting into that stuff. And so put your thinking caps on, because today's lecture is probably going to be one of the more difficult ones. And if there's any lecture where if you don't understand it, you'll probably fail the course, it's this lecture. So make sure you understand what goes on in this lecture, because the concepts taught today, and I guess a little bit of next class, are going to be very, very critical in being able to do the rest of the course. Not just the coming assignment, but all future assignments from now on. Okay. Before we get into Module 5, we still have a little bit of stuff we need to finish up in Module 4. So let's first finish that stuff up. Okay? So up till now, we've gone over Modules 1, 2, and 3, and a little bit of 4. Modules 1 talked about basic data types and natural numbers, and we saw how we could trace programs and go from a mathematical expression down to a single value. Module 2, we saw the design recipe, and in Module 3, we saw the symbol and the string data type. Now in Module 4, we got introduced to the first compound or complex data type. We got introduced to structures. And structures were our way of making our own data type. We could make students, we could make posins, we could make any kind of data type we wanted to. And that was our way of, defining our own data types. Now, whenever we defined a data type, it looked like this. We did define struct with struct name. Okay? I'm just going over very generally. And then over here, we had, or I guess not field, parameter 1, parameter 1, parameter 2, and as many as you wanted. Parameter, let's just say n. Parameter n. Okay? So this line right here, whenever we did this, this was our structure definition. So this is called a structure definition. This is not actually a data definition. It's very important to understand that when we do a line like this, when we define a structure, we're not actually defining a data type. This is a structure definition, not a data definition. So we have data types like numbers, strings, symbols. This is not a data type. To define a data type, we have to write a comment that talks about what the structure is. So the data type will be always in comments. Okay? So I'm going to have a comment, and the comment is going to be S name. And notice how this is capital and this is small. It's very important to realize the difference. This needs to be capital because that's your way of saying this is the data type I'm defining. You're defining a data type called S name is, and then you're going to say make S name. And then you're going to say the type of these parameters. So you're going to say like nat, num, str, dot, 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 all the way up to like whatever the different parameters are. Okay? And this line right here is the data definition. This is a data definition. This line is what tells us we have defined a data type called sName. And it consists of fields or parameters, well, these parameters right here. Okay? So let's go over a quick example to demonstrate this idea. Yeah?
What's the difference between a parameter, an argument, and a field?
So a parameter, a field is a word that I'm just using that you guys actually shouldn't, that's just a word that I use because that's not a word that you guys need to know. Parameter and argument are the only words that you guys actually need to know. Parameter is the actual variable, I guess the actual variables that are within the function, and an argument is when you specify a specific value for a parameter. So if you have like a function f of x equals x squared, x would be a parameter, and then when you specify like 2 or 4, like f of 2 or f of 4, the 2 and the 4 are arguments. And a parameter is just it's a variable. It's the variable within the function. Okay? Okay. So this is essentially the basic template that we will use to define different data types. Okay? So with this being said, let's actually go over an example that uses structures. So generally speaking, whenever you're given a question, you're going to be provided with the data type. So this is kind of how questions on your assignment 4 look like, and I'll show you another one. So define struct student, and the student will have a name, an age, and a student ID. Okay? So this is, once again, the structure definition. This is not the data definition. Okay? Now after this, we're going to have a line that is the data definition. So we're going to say student is a, and then make student. And this is where you specify the types of the different parameters. So we'll say the name is a str, the age is a nat, and the ID is a nat. Okay? And this is now given us a data type called student. So now we can have functions that take in students. We can produce students. We can do whatever we want with students. Okay? Actually, before I continue with this example, I just want to go over the high-level overview that I was going over just a few seconds ago. So when we were looking at this, the one thing I want to add on, I already talked about it last class, but whenever you do something like this, Dr. Racket provides you with 3 functions. And that's the biggest takeaway that we need to understand from this module. Structures are defined with these 2 lines, well, technically with this line, and then the data definition is defined with this line. And then whenever we do this, Dr. Racket will always provide us with 3 functions. So function 1 is called the constructor. And this is this function, the make sName. So this is make sName, and this is where you pass in parameter 1, parameter 2, parameter n. Okay? Technically, these would be arguments actually, because you would be, or actually, no. It would be the type, sorry. Type of parameter 1, type of parameter 2, and type of parameter 3. You're passing in a natural number, a number, or whatever it may be. After this, we have the selector. And this is, first you call it the structure, so you say sName, and then you say parameter I. You pass any one of these parameters. You pass in any one of these, and then you pass in some variable. Okay? Function 3 is called the predicate. And all this does is it tells you if something is of your type. So here we just do sname, question mark, on some variable. And this will produce true or false. So it'll produce a Boolean. Okay? So this is the most important thing about structures. Whenever we define a structure, we're given these three functions. Okay? All right. So back to this example. So write a bracket function called oldest student that consumes 3 students, stud 1, stud 2, and stud 3, and returns the name of the oldest student, or 0 if it is a tie. Okay? So as you can see, we're now at the point where we're writing functions that take in more than just numbers, that take in more than just strings. We're writing functions that take in students. And we're solving questions that ask us, who is the oldest student? Okay? So that's what the goal of this function is. Write a function that consumes 3 students and returns the name of the oldest student. Okay? Now, at this point, I'm going to stop writing the entire design recipe for all the examples I do, simply because that's something that we talked about in Module 2, and you guys should be comfortable with that. I'm only going to write the important, not the important, the tricky parts of the design recipe that might not be so obvious. So for this question, the tricky part of the design recipe would be the contract. Okay? So let's write the contract. So it would be oldest student. It consumes 3 students. Okay? So it consumes student, student, and student. Right? These are the 3 parameters it consumes. And it produces. What does it produce? It's not a string. It produces any of str and nat, because it produces 0 if it's a tie. Okay? So that's the contract here. It consumes 3 students and it produces either the string or the number 0 if it's a tie. And that's why we have any of here. That's our way of saying we produce more than one thing, or any of these things. Okay? Now we can define the function. Again, I'm not going to do all the design recipe parts. Define oldest student, and it takes in stud 1, stud 2, stud 3. Okay? So what are we going to do here? Well, notice how for this question, there's going to be 4 possible things produced. There's going to be either student 1's name, either student 2's name, student 3's name, or 0. These are the only 4 possible things that can be produced. Right? We can either produce student 1's name, either produce student 2's name, produce student 3's name, or produce 0. So, let's have 4 conditionals. 1 condition for each of these. Okay? So, con. So, for the first condition, when student 1 is the oldest, what should we check for? We want to see if student 1's age is greater than student 2's age and it's greater than student 3's age. Okay? So, and greater than student dash age. This is our selector. So we're selecting the age of student 1 and we're comparing it. We're saying, is student 1's age greater than student dash age of student 2? Okay? Is student 1's age greater than student 2's age? And is student dash age, is student 1's age greater than student 3's age? Okay? Only if the age of student 1 is greater than the age of student 2 and the age of student 1 is greater than the age of student 3, only in this case do we produce student dash name of stud 1. Okay? Next, when student 2 is the oldest. Well, in the first one, we already knew student 1 was the biggest. So, in the second one, we just need to check if student 2 is older than student 3. Okay? So, greater than student dash. Actually, no, we need to check. We need to check both. We need to check both. So, same thing. Greater, it's the exact same thing. We're just replacing student 2 with student 1. So, greater than student dash age of student 2. If that's greater than the age of student 1. If that's true, and greater than student dash age of student 2. If that is bigger than the age of student 3. Okay? So if the age of student 2 is bigger than the age of student 1 and the age of student 2 is bigger than the age of student 3, then return student dash name of student 2. Okay? Now I'm not going to write the third one, but it's going to be the same thing with student 3. So and greater than dot dot dot, and then greater than dot dot dot. So this is for student 3. We're going to return student dash name of stud 3. Okay? And then else return 0. Okay? Yeah.
Is it necessary to use like the AND function on all three cases? Because like if the first case is false, then AND immediately evaluates the false. And the
Yeah, so that's a good question. The question is, do we actually need to use AND here and here?
Because like in the first case, when it turns to false, we already know that like student 1 is less than student 2.
So that's not entirely true. We don't know that student. So if we get to this condition, do we know that student 1 is not the oldest? We don't know that. We only, it could still be a tie. And that's why I included this AND here. If I said greater than or equal to, then you don't need the AND here.
If we check the main case first, like if they were equal first, then could we use like only one AND?
Yeah. So if your first case was you check them all to be equal, then your following cases you could reduce the amount of conditionals in each one. But the only reason we can't do that here is because there's a chance that it's a tie. Yeah. Good question. Does it make sense? Okay. Okay, cool. One more example that's going to be just a little bit more clear. Okay. So this is, we defined a student to be name, age, and ID, way up here. We defined a student to be name, age, and ID. What I'm going to do now is I'm just going to change the definition, okay? Because, like I said, we're making these definitions ourselves. There's no reason we just can't change them. Okay? So let's change the definition of what a student is. Okay? So this time, we're going to do define struct. Actually, define course with a name, a title, and a grade. Okay? And then here we'll say course is make course str net. Okay? So this is the course. Okay? Now we're going to define struct. We're going to define another student. And we'll say a student, we'll say he still has, or they still have a name, an age, and an ID. But we'll say a student also has course 1 and course 2. They're taking 2 courses. Okay? And now again, we need to define the data type of a student. So a student is a make student. Name is a string. Age is a nat. ID is a nat. What's course 1 and course 2? What's the data type of course 1 and course 2? They're a course. They're not a course. They're a course. Okay? So, course and course. Okay? So this is very important. We're talking about nested structures here. You have a structure, and it contains another structure. So you have a student, and it contains courses. And courses is a structure. And theoretically, we could have courses contain some other structures. And those structures could contain other structures. And you can keep doing this infinitely many times. You can keep having structures within structures within structures within structures. Okay? I think in this course, we're never going to get more than a structure within a structure. Maybe a structure within a structure within a structure. Okay? So, write a racket function that consumes, highest grade that consumes a student and produces the name of the course with the highest grade and 0 otherwise. Okay? So we're writing a function that consumes, well, let's write the contract. So what's the contract for this function? So we have highest grade, and it consumes a student, and it produces any of str nat. str, capital S. Okay? Okay? Okay. So how do we write this function? Define highest grade, and it consumes a student. We'll call it stud1. Okay? And what are we doing? Well, again, anytime you're going to be programming a question, always ask yourselves, what is going to be produced? Okay? So in this case, it's producing the name of the course with the highest grade. So the only things that can possibly be produced is the name of course 1, the name of course 2, or 0. Okay? So we need 3 conditions, one for each of those. Okay? So cond, one condition for when course 1 is the highest grade. Actually, I'm going to do this example with having 0 returned first, so we can see short-circuiting within our conditions. So the first condition, let's have it such that there's a tie. Okay? So equals, what are we going to be comparing? We're going to go into this course, and then we're going to go into the grade of that course. Oh, whoa, sorry. We're going to go into this course, and then we're going to go into the grade. Oh god. Okay? So what are we going to check? We first need to go and access course 1 of this student. So we need to do student dash course 1 of this student. So we need to do student dash course 1 of stud1. Okay? This gives us a course. Student dash course 1 of stud1, this gives us a course. Because look, up here, we know course is a course. And we're accessing this field. Okay? So after we access this, well, now that we have a course, we need to access the grade within the course. So we need to do course dash grade of this whole thing. That is not clear. Course dash grade of that whole thing. So check if course dash grade of student dash course of that one is equal to course dash grade of student dash course 2 of stud1. Okay? So if the grades for both these students are equal, return 0. Okay? Now let's see what happens if student 1 has the highest grade. Oh, sorry. So next condition, if greater than course dash grade, same thing. Student 1, student dash course 1 of stud1. So now we're asking, is the grade of course 1 bigger than the grade of course 2? So this condition asks, is the grade for course 1 bigger than the grade for course 2? Yeah?
So shouldn't we be comparing course 1 and course 1 of student 1 and student 2? I guess.
There's only one student. So this function takes in just one student. And all it does is it looks at, so we could have a function that actually takes in 2 students and it compares all 4 grades. But because we're only doing one student, we only compare 2 grades. Okay? So if the course dash grade of student 1 is bigger, then what are we going to do? We're going to return the name of course 1. So we're going to do course dash name of student dash course 1 of stud1. Okay? We're returning the name of the first course. And then else, Well, now this is where we short circuit. We know they're not equal. We know course 1 is not bigger. So the only thing left is for course 2 to be bigger. So now we know course 2 has the highest grade. So else, return course dash name of student dash course 2 of stud 1. Okay, does that make sense? So this is an example of structures within structures. And again, none of this is complicated if you understand those 3 functions: the selector, the constructor, and the predicate. The selector is the most important one, as you can see. As you can see, we're using the selector far more than we're using the constructor or the predicate. We still use the constructor and predicate, but we use them far less than we use the selector. Okay? Does this make sense? We're almost done with structures. We have one more topic to cover, and then we're going to be moving on to lists. This is everything, for the most part, you need to understand about structures. Does this make sense? All a structure is a data type. You define your own data type. And then, this data type has different fields. And those fields can be strings, numbers. They can even be structures. You can have structures within structures. And then all you need to do is you need to access the different fields within the structure and work with them, like that. Okay? Okay. Cool. Okay, so the only thing we haven't talked about when it comes to structures is something called templates. Okay? So I'm skipping over some of the slides because in this module, most of the slides are just examples, and I'm already doing my own examples, so I'm not going to go over the examples because you guys can just go over the examples on your own. You already have several examples that I've been giving you. I'm just going over the theoretical stuff. Okay? So templates. What is a template? A template, believe it or not, is a very small part of this course. So if you don't understand it, don't worry too much because it's kind of its own section. Okay? A template is essentially our way of generally writing code. So when we do define some function and then we write the body of the code, there is actually guidelines that we can follow when we write the body of the code. And the guidelines that we can follow is a template. So what is a template? A template